right, up until this point, we've only been dealing with discussions about acids and bases under the Arrhenius theory. And under the Arrhenius theory, and I'll try and put that up here, you have your acids that are going to produce H plus or hydronium, H3O plus, as the only positive ion in solution. Your Arrhenius bases will only produce hydroxide, OH minus, is the only negative ion in solution. Now, what we found was, or scientists found, that not all, especially bases, had hydroxide in them, even though they had the same types of properties as bases. So they had to expand their definition of of acids and bases, which led to the Bronsted-Lowry theory. So we're going to talk about Bronsted-Lowry acids and bases. This you're going to see in terms of Regents questions referred to as the alternative acid-base theory or the other acid-base theory. For whatever reason, they never actually referred to it as the Bronsted-Lowry theory. So a Bronsted-Lowry acid is very similar to an Arrhenius acid in that it's any species that can donate a proton H plus to another species. So it's going to produce H plus, which gets given to the other species that it's reacting with. So very similar. Bases are much different. Under the Bronsted-Lowry bases, there is no discussion of hydroxide. It's just going to be any species that can then accept a proton from, this should say, another species. Okay, so in this case, we can't just look at the formula of each individual acid or base under this theory. We have to look at them reacting together. So for us, we are always talking about our two reactants. Remember, our reactants are the species that are on the left-hand side. The right-hand side are their products. That's just what they are going to turn into after the reaction. So we have to know if the H plus is going to move from HF to H2O, or is it going to move from H2O back to HF? And we have to look at what they become. So if I had them react where the H plus moved from HF to H2O, that would mean that H2O would become H3O plus, right? And then HF would be one less hydrogen and you get F minus, which is what I have. If it would have moved the other way, where H2O would have donated a proton to HF, well then this would have looked something like H2F plus OH minus, okay? And that's not what we have. So in this case, HF is becoming F minus, and H2O is going to have to become H3O plus. And it does that when that HF is going to donate and transfer a proton over to H2O. So because of that, HF is the one that's donating the proton. It's giving it up. So HF is going to be our Bronsted-Lowry acid, and H2O is the one that's going to be accepting that H plus. So H2O is our base. Now in honors and AP, we get into conjugate acids and bases that involve the products on the right-hand side. For Regents chemistry, we only care about our two reactants, which one is acting as the Bronsted-Lowry acid and which one's acting as the Bronsted-Lowry base. So the Bronsted-Lowry definition is important because it explains substances like ammonia, NH3, which is on, keep in mind, table L, which is our bases, why it will act like a base in water, even though there's no hydroxide in it. When NH3 reacts with H2O, what we see happen is that, again, look at what they have to become on the right-hand side. Which way is it going to move? Is it going to move from NH3 to water? Well, those don't match up what would happen. I would have like H3O plus over here. Or does it move from H2O to NH3? That makes sense, because if I take one away from H2O, H2O is going to become OH minus, and if I transfer it to NH3, NH3 is going to be gaining an H plus, so it will become NH4. So this is why we need the full reaction, because we have to see what they turn into to figure out which way or what's the movement of the H plus. So that means then that our acid has to be what donates the proton, so that would have to be water. So water can actually act as an acid or a base. And then ammonia, which is accepting the H plus, is going to be our base, NH3. Okay. right, so if we look at a couple of these examples, you could pause it right now and just check over what you come up with. So if we look at this first one, we're going to see that HCl plus water is going to produce H3O plus and Cl minus. So if I focus in on just the Cl minus and the HCl, that must mean that this H plus was given to H2O, okay, in order to make those two products. So HCl is one that's donating. That's going to be the acid, HCl. And then H2O is going to accept that proton, so that is going to be the base. Remember, only picked from the left-hand side. Okay, these guys we're not going to be dealing with our Regents questions. All right, in this next one, I have HNO3 plus water. If I look at this, I'm going to see H is going to move from HNO3 to the water in order to make these two products, which means that HNO3 is my acid, is going to be donating the H plus, and then H2O is accepting that, so that's going to be my base. And again, you should always be looking at just the movement between these two on the right. Okay, you're going to have a practice that you could choose to do just to make sure you get the hang of it, and then you can move on to the quizzes so I can check your understanding and see if you have some evidence of learning.